All right, let's take a lot of what we've done and put it all together here. Are we ready? We're going to take a word problem, all right, with all of those vocabulary terms about adding, subtracting, multiplying, and dividing that we went through a few lessons ago, and use let statements to create these equations that we can solve. And let's see if we can put it together with consecutive integers. So say we have two consecutive integers, all right, just two numbers, whose sum, oh boy, sum is 11 less than 3 times the smaller integer. We want to set up let statements that give us the expressions for our two consecutive integers and then use these expressions to set up an equation that solves for them. So again, you can go ahead and guess and check. I'm going to go ahead through the process, and I think I'm going to beat you. Pretty sure I will. So this is going to be the first number, always n or x, okay? And that's just the first consecutive integer, all right? Easy peasy. Next up is, well, if they're consecutive, just one more. So the second, and I'm just going to shorten this up, CI, consecutive integer. And that's all we needed. We just needed two numbers, all right? A let statement for two different expressions representing those numbers. Now it's up to us to break this down. Underlining, annotating, do whatever successful strategy you need to be able to get this. Reading it more than once is definitely a good one. Let's start back at the beginning. Two consecutive integers whose sum is. So we've identified the equal sign. There it is. So I need to come up with this. These are our two consecutive integers, and we need to find their sum. So simply take them and add the first one plus the second one. And giving some color to this definitely helps you see the first and the second and then being added. Now the next part is that being able to break it down and come up with those operations. 11 less than, remember that 11 less needs to be held off because it's after the problem. So after what? 3 times the smaller. Well, if we were to look at this, which one's smaller, the first or the second? Clearly the first one, because we added 1 to it to get the second one. So it's going to be 3 times the smaller, so just 3 times n. Now we can go back and do the minus 11. All right. So from there, we want to go ahead and combine like terms. 1n and 1n is 2n plus 1. This is equal to 3n minus 11. Now my rule of thumb, whenever we're solving this with variables on both sides, move the smaller coefficient, right? So we're going to go ahead and subtract 2n on both sides, leaving us with 1 equaling 1n minus 11. Pretty simple from here. Property of equality, we want to add 11 to both sides, and then 1 plus 11 is 12, so 12 is the first number, okay? And then all we have to do to find the second number is add 1 to that. So the two numbers that we were looking for that are right in a row, 12 and 13. All right. Let's do one more, and this time let's focus on odd integers, okay? So I'm thinking of 3 consecutive odd integers. That's going to be important for our let statements. When I add the larger 2, the result is 9 less than 3 times the smallest of them. What are the 3 consecutive odds? Before I go through the underlining and the annotating, I think let statements would be a great place to start. So again, even if it's an odd number, the first number is just a variable. So let this be the first odd integer and consecutive at that matter, okay? And then the next one is not one more because odds count by 2s. So this is 2 more. So this is the second consecutive odd integer. And then the third one would have to be 4 more. So this is the third odd integer. If I just did 2 more, I'd have the same number. It needs to increase by 2 every time. Now, it's time to go back and read. When I add the larger 2, the result is, there's my equal sign. So I'm going to focus just on this side, adding the larger 2. Well, the larger 2 must be the second and the third. So that means I'm going to take n plus 2 and add it with n plus 4, the larger 2. And we can see how that's a number and that's a number. Now these are equal. All right, now we can read the other side. 9 less than 3 times the smallest. There's that word less than again, trying to get you to write the 9 first, but we know better. We want to do 3 times the smallest. In this case, it's just n. Now we go back and subtract 9. We got a little bit of work here to simplify on this side before we solve. So 1n and 1n makes 2n, and then 2 plus 4 makes 6. Over here, this can't be subtracted, so we keep it 3n minus 9. At this point, it should be pretty routine just to go through, use your equation steps, the property of equality coming in big here to subtract 2n on both sides. Now I need to add 9 on both sides, and voila, 15 is equal to n. Is that an odd number? Yes, a great way for you to check yourself. So I go back and I say if the first number is 15, how can I find the others? Simply just substitute and add the amount. So this would be 15, 2 more, 17, 4 more, 19, and there we have it. The 3 consecutive odd integers that we were able to come up with. Not so bad once you set up those let statements.